Welcome to the ASW Vault. In June 2022, Keith Hoodlet joined us to celebrate our 200th episode. Keith started the Application Security Weekly podcast with episode 0. We talked a little bit about that early era and what he's been up to since. Then we covered some AppSec news, including an article from Phil Venables on career advice and professional development. Keith shared some of his career journey and how he's helped build both AppSec and DevOps teams. A lot of the technical parts of AppSec change. You might even notice that in some of the other news we talk about in this segment, but an AppSec career is as much about working with others, delivering and receiving feedback, and choosing what types of specializations appeal to you. Enjoy ASW 200, and stick around, new episodes are in the queue.
This is a Security Weekly production for security professionals by security professionals. Please visit securityweekly.com/subscribe to subscribe to all the shows on our network.
It's the show to learn the latest tools and techniques to understand DevOps, applications, and the cloud. Your trusted source for the latest AppSec news. It's time for Application Security Weekly. Okay, Keith, you knew the rules here, how to get the advertisements, get the announcements out of the way, but now we get to talk, and we get to talk about the news. But before we do that, as you said, you started off this podcast with number 0, and it's been a little bit since we've had you back on the show. I'm not sure. I've got good news and bad news. Good news is we love having you back. The bad news is I'm not sure we've solved anything. We still have top 10 lists with cross-site scripting on it, SQL injection. We're going to have a OGNL vuln we're going to talk about shortly in Java. So I don't want to bring us down right from the very beginning, but in the time that you've been away, what have you been up to? Give us some hope for the future. What's some optimistic work that we can think about that you've been working on?
Sure. Honestly, I don't know that we've actually solved anything yet. We're trying, though. We're trying, right? Like we're bringing things forward. And since the last time we spoke, I joined GitHub. I'm actually a code scanning architect, which part of the reason I joined is because it gives me a lot of hope being here. I mean, the transition that I'm starting to see with very large, very technically astute organizations around understanding how the version control system is the ideal place to put security, because it makes security less of that ambulance driver dropping off critical problems and more of that, wing in the hospital that is part of that process of getting applications healthy and making them stay healthy over time. I don't know. Things are bright. I've written quite a number of blog posts recently. So for anyone that's interested in checking out some of that writing, it's securing.dev. I've covered the static analysis space pretty heavily. I'm starting to write an entire series on DevSecOps essentials. I feel like we're making progress, but I'll tell you, Mike, a lot of these ideas, a lot of these concepts are probably 5 to 10 years old, and we're just starting to see implementation of them, much like the difference machine, right? It's taking a long time for companies to come around to these concepts, and it's going to take even longer for them to actually start addressing the problems that they have. Because let's face it, if you're a business, you're not going to invest in changing the language of your key money-driving application unless you have to. But we're learning more and more that memory-safe or type-safe languages like Rust are a really great way to secure and shore up the security of your applications long term. So I don't know. I feel like technical debt is maybe the biggest reason why we continue to see so many challenges out there. I mean, key example is the conversation we're going to have around Confluence here toward the end of the news segment. But even companies like Google, for example, still find vulnerabilities. They had $8.7 million in rewards in 2021. And let's face it, Google is one of those apex companies when it comes to implementing and performing things securely, and they continue to have problems. Where, by the way, they're covering all 5 layers of the DevSecOps essentials, as I call them, right? Like, if Google can't secure themselves, I don't know that anyone in the world can say they're perfectly secure at this point.
No, and it took, if it takes, 180, 190 years to go from version 0 to version 2, that I think that at least gives us hope that we can maybe in another 20 years get our OWASP top 10 list down from 10 to maybe 8 or 9. But as you point out, Google
once again, they're talking about their top payouts for the winners of their 2021 GCP Vulnerability Reward Program, VRP. Lots of acronyms today. But a couple of the reasons I like to highlight this is one that you already touched on, is that we talk about Google, and when we talk about Google, that's the shorthand for here is a company that has buckets of cash, high investment explicitly into security, both security engineering teams as well as security research for that matter, as well as external bug bounty, but they still have vulnerabilities, $100,000 vulnerability awards, as they're pointing out from 2021. So it's great that you're highlighting that. And another area that I like to highlight is also just reading through and learning what were some interesting either trends or what are some interesting tech stacks that people are poking at to find either $10,000 or $100,000 plus worth of bounties. And you mentioned you've been blogging and getting into that securing.dev essentials. I'll drop the link into our Discord shortly. But one of the vulnerabilities here that I liked was about bypassing that identity-aware proxy. And once again, it's a good article. It's always good to read just an attacker-minded approach to looking at an attack surface. Here is a proxy. Here is OAuth. How can I, as an attacker or a researcher, pick it apart? And I think the other part for me that I wanted to mention this is that OAuth is pretty pervasive, especially throughout a Google ecosystem, if everything has, sign in with Google. But in many modern applications, we're moving towards that sort of federated authentication mechanism that is grounded in OAuth, and there's a lot of still problems that can come up there. So sort of a call to action, if you will, for anyone who wants to either get into more bug bounty research and find out where are some profitable points, or just understand what are the modern technologies we should be playing around with rather than some old rusty difference engines.
What I love about this is this attack goes right after the core authentication mechanisms of their application stack. And we talk a lot about in this industry the move toward zero trust, right? And so this is sort of like you have to trust something somewhere. And this is the place where you normally have to do that. And in this case, a bypass against that authentication mechanism can lead to a whole host of issues down the line. And so it's really great that, that was the 133337. I think I got enough threes. Maybe I'd have had an extra three in there. Anyways, $133,337 paid out for this bypass, which totally worth it, right? I mean, from a Google perspective, can you imagine the sort of harm that might come to their user base or to their internal users when it comes to this sort of bypassing mechanism? Pretty stellar work. I really liked the. I thought it was sort of funny, the VM takeover via DHCP flood. It's like, really, like you can just take over the VM by flooding it with DHCP packets. That seems so trivial, but I'm sure in the real world it must happen somewhere where you just sort of lock up an engine that's doing some sort of authentication checks, and suddenly, boom, you've got access to the VM. That's pretty massive.
It's fun, and I think the theme that I was looking at was here is OAuth. Here is DHCP, so a little bit of protocol analysis can get you, what was that, $70,000 or so? And I think there was and then the sequel also at the end, I think. So none of these are obscure or hyper new or things that are uncommon either to Google themselves or to the industry at large. So it's still interesting to see that to the point you were making earlier. There's still that long road ahead of us to figure out what are the better ways of secure architecture, secure implementations, and I think it's fair to say in each of these 4 points, the winners of this in this Google article, none of them, I believe, are memory safety issues. So that's not to say that we shouldn't be moving to Rust to go getting away from those memory unsafe languages of C and C++. It's just as my bingo card drumbeat, if you will, to mix a whole bunch of metaphors, is always we can solve that attack class of memory safety issues, but we're still going to have plenty of others because there's still all kinds of other mistakes that we can make that we still need to pay attention to.
Oh yeah, this is the low-hanging fruit, right? If you think about it from that perspective, this is the sort of stuff that they weren't able to catch internally, and that at the end of the day, when we start to see those being the bugs that people are reporting against, we've made a lot of progress at that point, right? So what I would say is some of them are pretty interesting attack vectors, but the remote code execution stuff, I mean, the fact that you see some of it exposed Java JMX ports, I mean, it's like, oh God, when is Java finally going to just kick the bucket? But you're right, Mike. A lot of this stuff is, granted, pretty advanced. I mean, it's not the traditional put in SQL injection, get credentials back that we've seen in the past. But to that point, I would expect them to catch those things early and to remediate them early. That being said, they had a command injection on Google Cloud Shell, where it's like, yeah, you probably forgot to escape something somewhere, or a regex pattern just didn't match quite what it needed to, and you run into problems. And so we'll be seeing these sort of application layer attacks probably for years and years and years to come. They'll just change the format. That'll be template injection instead of command injection. It'll be RCE via remote shell callback, or you name it, right? It'll be all sorts of other problems that will just start to happen because, to the point that we made earlier, Google has to trust somebody somewhere, and they're probably using a lot of open source software in their ecosystem that they've got to continue to patch and maintain and update. And, well, at some point, something in there is probably going to become vulnerable and then be sort of trivially exploited, and then they have to go run the gamut again. I know we didn't cover it in the news segment, but it's sort of like the conversations that have happened recently from CISA around Shields Up. And we're sort of in this permanent state of Shields Up now. And how do we prevent burnout and fatigue from that sort of experience for all of the people in security? I don't have a good answer, but yeah, this is a marathon, not a sprint.
It is. And you made a couple predictions there too. So we'll make sure to have you back on in episode 2000 to see how many of those came true. Spoilers, I think you're going to be spot on for all of them. No worries. But you did mention Java too. So let's skip over to Java. There is a unfortunate combination of words: unauthenticated remote code execution vulnerability. So not a great combination from an AppSec perspective. This, of course, was in Atlassian's Confluence. And also, you mentioned not necessarily one of our favorite words, but our favorite marketing term of zero trust. And things like Confluence were potentially exposed on the internet in zero trust setups, in the sense of companies just putting them there so you SSO into these devices, and people are going out and scanning. And in this article from Rapid7, showing just how simple it is to exploit the OGNL, or OGNL if you really want to be pedantic about the pronunciation, injection vulnerability here. But I think, to me, rather than belaboring the point of poor Atlassian, which in the past 2 weeks, hopefully everyone has gone and patched your instances, this kind of points to, why do we have Java has problems, but why do we have something like the OGNL anyway? And here I'm going to have to admit up front that Java is actually the language I'm least familiar with in my history of AppSec. But even reading into it, the idea of reflection, the idea of being able to change the call graph and change execution of a process, as it's running, it does not engender warm fuzzies from a security perspective. It's always like, ooh, do we really want to do that? What's like design patterns is it really helping us with? Is it solving? Because, wow, this and the last couple of years, we've had a lot of these exact same types of injection vulns. So I'm not sure where this falls on your particular radar, Keith, but how did this look to you?
Oh, when I saw it, and I initially saw, the rule sets that Confluence had put out around, blocking the $ brace, like open brace on your firewall, I was like, it's template injection. Why is there template injection in my Confluence? Honestly, I laughed because back at DerbyCon 2017, I've got my little poster over here from the training that I gave with Casey Dunham. That was one of the attack vectors we trained with the AngularJS sandbox. We actually taught all of our students how to exploit template injection and get full remote reverse shell out of just a Docker container in this case, but from an application using this. And I was just like, what are they using? And initially I started asking around. I was like, are they using like AngularJS and they just haven't updated the language? And it's like, no, they're probably using Spring. And I was like, ugh, like I didn't actually get into the details at that time, but seeing this, I'm like, yeah, one of the dependencies that a lot of web application front ends are going to have is that whole template mechanism and how to pull back things from a template to be displayed back on the page. And so at the end of the day, I think a friend of mine once said, all of security, at least in the application security space, stems from when developers confuse input as code. And template injection is the representation of that. If I couldn't give a better one out there, this is like the way to do that. And again, template engines are the thing that these web apps are depending on. It's the backbone of them, and they're usually open source engines. And so it's going to be one of those vectors, if you're in the application security space, that you're going to be going after for a long, long time. I know Portswigger has done a really good job on doing a lot of write-ups around template injection. So that's where I usually go to get all my little, like, what command line arguments and what other things do I need to pull into this template injection to break through the sandbox or whatever sort of protections they've put in. So great on Rapid7. I was a former moose myself at Rapid7 for a little while back in 2017. So good to see that they're continuing with the great security research and a really nice write-up with, by the way, really good code snippets and code coloring style. I like it.
Yes. One of the things that we love to highlight on the show are write-ups so that others can emulate those write-ups in the sense of emphasizing communication. And I'm leaving that as a little bit of a teaser for some when we start to talk about some career advice. But before we get there, I don't want to leave the vulnerability section quite yet. I'm going to jump over to an article about Fuzz Introspector. So the last couple of weeks, John and I, Keith, we've been talking about OpenSSF and the investment of money. So good investment, money and time into the open source ecosystem of looking at the top 500 NPM packages as a little bit of a callback to my intro, as well as just investing in pen testing, code review, re-implementing some a handful of applications into Rust, into memory safe languages. And one of the areas is my personal favorite, fuzzing. And this one is not so much about, it's about the investment in fuzzing, but this one has a little bit of I think a hook into being able to generalize engineering concepts to it, because it's saying that on the one hand, yes, we have fuzzing, but oh, look, the fuzzing has missed some critical vulnerabilities. So here, we want to say, if we're going to use a security tool, and that security tool isn't going to identify critical vulns, what's the problem here? Where's our gap? Is it a fact that the tool itself fundamentally wouldn't be able to? Do we need to improve something in the tool? Are we going to have to use a different type of tool, a different approach? And so it's really neat to see that this fuzzing effort, it has some ways of automatically looking at coverage, doing some postmortems, doing some case studies, if you will. They've only got 2, but some case studies on 2 vulns that the fuzzing didn't identify, but went through, did some analysis, did some tooling so that they can demonstrate for XPDF, for this other app, and then in general for any other app that is being targeted with fuzzing. How do we make sure the fuzzing can be effective? So it's this type of feedback loop that I think is good for any security tooling. That's a good message to take away from here, as well as, quite honestly, it's a fundamental, just a software engineering type of test. It's that question number 4 in your threat modeling. How well did we do? And so that was enough. I think I've exhausted my soapbox on this to try to sneak some fuzzing in, but I'm not sure. How does fuzzing land for you in your? I
mean, it's the dynamic tools for compiled applications, right? It's the one thing that I always found sort of difficult to implement when I was leading the team at Thermo Fisher. Yeah. So really good to see, additional coverage, additional work happening in the fuzzing space, because quite frankly, there's not a lot of this. I mean, I always went back to American Fuzzy Lop or AFL for a lot of the things that we were doing. But again, thinking of how to run that at scale effectively, get the results out in a way that is useful to your development organization to sort of prove that mitigations or that remediations have actually actually worked the way that you intended them to is really powerful. And it is one of those areas that, and before we got started on the call, I think that we're going to see more investment into this area because let's just face it, a lot of these languages, a lot of these applications that are just out there are going to be long in the tooth. And quite frankly, we're going to need to make sure that we have security tooling that can continuously check for those vulnerabilities in the long run. Of course, the hardest part is always getting them remediated, especially as talent, shifts into new industries or changes their focus. And the C and C++ world, well, not a lot of people are writing that as their sort of first language today. And so I hope that we fix a lot of those problems now and get those architectures in the way that they need to be before those people start to leave the job market.
Yeah, and that's what's also good about to see from the OpenSSF investments, that they avoided the trap of we don't need to know yet more vulnerabilities we have. They have a long list of we know what our problems are. We need help fixing them. And so a lot of that investment was into fixing them. And you're teeing up some great segues into talking about careers. But before we talk about maybe the present and the future, let's take a little bit of a look to the past and protocols itself. And HTTP3, it's been officially blessed as a standard. It's been officially standardized. And, a little bit, I always enjoy looking at protocols because they tend to be rather small, but it's always fun to think through the threat models of the state machines they set up. And for the longest time, HTTP1 was all we needed. HTTP1 has driven, our current monopolies, our current behemoths of web application, industry out there, as well as web security, as well as lots of open source. And there hasn't been much change there now until recently, HTTP2 and now HTTP3, in the sense of what the protocol looks like, how it's, how encryption has now become, rather than just that really strong suggestion, a nice baked into the layer of it, but it's still just shuffling back and forth, get requests, head requests, posts, etc. And I don't know necessarily that moving to HTTP3 has a big implication for the application layer vulnerabilities, our layer 7, what everyone's building out there with their pick your favorite code in your templating engine. But what I will have a little bit of prognostication on is that when we see this migration to HTTP3 and we see some backwards compatibility, speaking of Portswigger, he's already identified with HTTP request smuggling, some of the how HTTP2 to HTTP1 interfaces and that kind of reverse proxying has introduced some vulnerabilities around request smuggling. So these are the areas where the protocol itself may have a good design, but the implementation, we're going to stumble a bit along the way. So just a good area to pay attention to for the AppSec teams out there as they're layering their applications on top of these new protocols.
And I suspect the attacks here, people that are going to go after applications that are running HTTP3, well, those applications are still going to need to support HTTP2 and maybe even 1 in some cases, depending on the customer base that is using that application. And so to that respect, I would think that a lot of the attack vectors are still going to focus on that layer 7 approach, because let's face it, if you're attacking the protocol that it's running on top of, you're probably a state actor, and you're probably trying to grab all the traffic so you can de-encrypt it later. Your problems at that point are an entirely different threat model than what most teams are going to be focusing on from an application layer perspective. So to your point, keep an eye on this from a request smuggling perspective, because you might have an HTTP3 where it is mostly secure, but then somebody downgrades and then suddenly you have all the problems that downgrading brings with it. So it'll be interesting to keep an eye on this, but I did love some of the charts, and especially, earlier when we were talking about this before the show, Mike, seeing that chart on version by request share over time, and Chrome just consumes 80% of the request share. It goes to show how much of a monoculture we've sort of been driving toward when it comes to the browser landscape, which of course brings its own host of problems that I'm not even going to get into.
Absolutely, yes. Browser is the new operating system, and I think You also prompted me to think about, even with these vulnerabilities that may come up, there was just I think a Kerberos vulnerability that came out last night that was about new line handling. So even with HTTP 1, HTTP 2, HTTP 3, there's still going to be lots of, I think, implementation nuances and some vulns defined about whether they be bypasses based on an extra new line or case sensitivity or some unexpected, multiple headers that bypass some expectations that are being set by regexes and so on. So probably still some good bounties to come. But let's shift to talk about a little bit more of the people aspect and the career aspect. You also mentioned, you were trying to scale at Thermodynamics what am I trying to say? The fuzzing, and we got to have an article here from Netflix about scaling AppSec, and it's pretty interesting some of the lessons that they share there, because it's not, which I think is helpful, it's not all successes. It's a little bit of things like, well, this didn't work as well for us, and some of the things that didn't work as well, perhaps, were if I'm reading this correctly, was the concept of pure self-service, the idea that we're going to shift left and we're just going to write a bunch of documentation, a bunch of guidance for our developers to say, if you're building something, go read here and make the decision yourself, but we're going to give you a lot of ideas. What it sounds like is more effective there is self-service comes from opinionated guidance, meaning we really think you should do X or Y, and secure defaults. If you're trying to do the problem in this way. And if anything, the shared responsibility hasn't gone so much from security onto the engineering team, but engineering principles, engineering effort onto the security team to pick up for them to be successful. So I think that was kind of the takeaway I got from this article.
Yeah, and this is one of the things that we learned pretty quickly at Thermo Fisher was around, providing not only the sort of tools to make this easier from an engineering perspective, right? As soon as we could provide templates, as soon as we could provide guidance, as soon as we gave opinions, we gave optionality, but it was optionality from a menu that we chose. And so that was really a very powerful thing to allow the team that I built over there to scale. I mean, we had at sort of the height of my leading that organization, I think 9 total people, myself included, and we were covering thousands of developers and thousands or hundreds at least, if not thousands of repositories and applications. And so the only way to do that with a team that small and a remit that big is you have to provide the templates and provide the opinions, and then when you need to, be that professional services help, as they also call out here. I really like the layers that they have of strategic alignment, professional services, and software engineering and automation. It's like, yes, you need all three, and by the way, those take different skill sets to be effective at. Yeah. So one of the very last sentences they have here, just above the little chart, is hiring early career AppSec engineers. My best advice, go find a bunch of college graduates who probably just graduated with computer science degrees and teach them security. You'll be very, very effective at scaling your organization, as I think that Netflix has called out here.
Yeah, and I think, speaking of options and lists, I think I said Thermodynamics instead of Thermo Fisher. So congratulations on your massive change in industry there. But joking aside, you're speaking of career advice. There's a great article from Phil Venables, and we've actually picked up, I think, just about maybe all but one of the posts that of the blog posts that he's made this year we've covered on this show. And this one is really good, and it ties into, career advice, the idea of how would you compose teams as well. And one of the things that stood out for me was placing a quote here, placing your bets on some big moves. And this is the idea that is an effort that's going to take not just like far more than many sprints, far more than a few quarters, just more like a multi-year effort. And a multi-year effort could be something like a fuzzing, if I want to try to make fuzzing happen. But more likely, I would also acknowledge, this is likely to be something around, we're going to refactor into a Rust, into a memory-safe language, or we're going to move, we're going to do a big lift in that manner, or we're going to attack we're going to target a particular attack class. We're going to say, not so much we want to get rid of XSS. Probably you could do that now and just say, let's adopt like a templating engine as our callback of the theme for something like React, but get into something more fundamental around like like default secure, failing secure for authentication problems or authorization problems, things so that when we see an OAuth mistake, that doesn't necessarily become super terrible. And I'm a little bit running out of steam here on concrete details. So let me pause here and help me out here. What stood out to you on this particular type of career advice? What would you really emphasize here, Keith?
One of the things I loved is the constantly look for and apply the 80-20 rule. And it's so true, right? Find that 20% of things that you can be doing that will have an 80% impact, because everything else after that is just marginal gain. And especially in large organizations with the sort of scale that you see from a security to developer ratios, the only thing you really can do is those 20%. And doing those really well has a substantial impact. If you are working on, the other percentage of problems that are filling that last 20% of impact, you're in a really good spot from a team and an organization perspective. I'll tell you, most companies aren't there. And so today, if I'm thinking of, if I were to build an application security team from the ground up again, it's some of those essentials that I call it in one of my recent blog posts. It's thinking about the 20% of the things you can be doing and the ways in which you can approach them to then have that 80% impact for the long-term scale that you're trying to achieve across an organization, knowing that security team is highly in demand. They're usually either very talented or very hard to find, that meaning you have to then train them, which is also a good thing if you can build that pipeline. But then they're also hard to retain because guess what? They're getting pulled in every which direction from a bunch of recruiters on LinkedIn trying to hire them for exponential salary gains. There's a lot of really good stuff here that as reading through it, I thought it was powerful, especially the be ambitious for the team, but stay humble individually. That was the thing that I always challenged my team with was what are the crazy ideas that you have? And then allocate a portion of your time to trying an MVP and seeing if it actually works. If it does, let's keep going. If it doesn't, you learned something. That's okay. And that was one of the most exciting things as a leader, I think, for me, was seeing the crazy ideas that the team had, letting them try them, and then letting them grow. That was, if it panned out, great. If it didn't, they grew. Either way, the team that I had, Eric Duran, Harrison Pham, and others, they've since moved on into other roles across the industry. And I'm amazingly proud of them, and I still continue to stay in touch with them because there's so much I can now learn from them with all the little experiments that they've done, and that helps me grow too, which I thought was great.
I love that. I love that phrase of just that's okay, because it sums up a lot of one of the other bullet points I did want to highlight before we wrap up here is that you always underestimate your impact, positive and negative, on others. And I think this ties quite strongly into the underlying theme of collaboration between AppSec and DevOps teams, that if you don't have that collaboration, if you don't have the empathy for how developers are being impacted by security controls, by security tooling, you're going to have a negative impact on them. You're not going to have that strong relationship. But if you can build things that are collaborative, if you're doing the engineering along with them, whether it is the paved road or you're solving a problem that improves the developer experience, that's a great way to have the positive impact, as well as just what you were saying there at the end, Keith, working with the own team to say, let's try something. If it worked, it works. Awesome. Let's lean into it. If it didn't work, maybe we could call that a fail, but let's also call that just that learning experience. That's okay. Figure out what was something useful to take on and iterate on top of it. Let's shift early and shift soon. And I think I will say, to wrap up here, from my perspective, as you said, be ambitious for the team, but stay humble individually. Still have to say thank you very much, Keith, for kicking off with episode 0, Application Security Weekly, so that we could have a great podcast, that we've got a listenership here. And it's great to have you here to celebrate a 200th episode with us. So thanks once again.
Thank you so much, Mike, and great to hear the outro music again. Stay classy, folks.